Okay, children, we have discussed what is uniform acceleration and non-uniform acceleration in the previous video. Okay, so now in this video, we are going to talk about very important topic, that is equations of motion. Okay, so we have four equations of motion. Of course, sometimes can be said five equations of motion if we take average velocity, but most probably we are dealing with academics 9th class. Okay, so we are going to learn four important equations of motion. Okay, so one is v is equal to u plus at. This is the first equation of motion. S is equal to ut plus at square by 2. This is the third equation of motion. V square minus u square is equal to 2as. This is fourth equation of motion. So the distance in the nth second nth is equal to u plus a by 2 into 2n minus 1. Okay, so these are the four equations of motion we are going to derive in this video. Okay, after deriving, we are going to solve some numericals to find the initial velocity, final velocity, acceleration, time, distance traveled. We use these equations of motion, but here we have one condition. These equations of motion can be used only when object is moving with uniform motion. Okay, so these equations of motion can be used only when object is moving with uniform acceleration. Then only whenever object is moving with the uniform acceleration, we use these equations to find the velocity, initial velocity, final velocity, acceleration, time, distance covered. Otherwise, normally we have other formulas. Speed is equal to distance by time. Okay, so velocity is equal to displacement by time. Average speed is equal to s1 plus s2 by t1 plus t2. If the half of the distance with one speed, half of the distance with other speed, 2v1 v2 by v1 plus v2. Such kind of formulas we use. When an object is moving with a non-uniform motion, we use those formulas to find the velocity, distance traveled, time taken to travel. But whenever object is moving with the uniform acceleration, to find those, compulsory we have to use these equations of motion. Okay, so now let us understand one by one. So now I am going to derive the first equation of motion. Okay, so v is equal to u plus at. What is v? Final velocity. What is u? Initial velocity. What is a? Change in velocity. It's a change in velocity. And what is t? Time. So in this formula, we have velocity and time. That is why this equation is also called velocity time equation. So first equation of motion is also called velocity time equation. With the help of this equation, we can find the velocity and time. This gives you especially the relation between velocity and time. This equation gives the relation between velocity and time. So hence it is called velocity time equation, right? So assume an object moving with uniform acceleration, because equations of motion can be used only when object is moving with a uniform acceleration. Let's say object is moving with a uniform acceleration this way. At this point, okay, that object has some velocity. Initially, when we see this object has certain velocity. That velocity is called initial velocity or initial speed. Speed of the object in one direction is also called velocity. So sometimes it can be said speed also. But because here object is moving in one direction. Okay, right. Whenever this object is moving with a certain velocity, okay, after some time t, the time is passed. Okay, maybe after 5 seconds, after 10 seconds, or it may be 15 seconds, or 1 minute, okay, or 1 hour. This object not moving with the same velocity. Velocity has been changed. After certain time, the velocity of the same object is not the u, it has been changed, it is v. So change is two types, either increase or decrease. Okay, right. So here initial velocity is what, Nana? What refers? U refers what here? U refers initial velocity. V refers what, Nana? Final velocity. T refers what, Nana? Time taken. Change this velocity. Okay. Here velocity has been changed or not? Changed. So what is the change in the velocity? So change in the velocity is equal to, change is denoted by delta, okay, or any quantity. So generally we do with this final minus initial. Whenever we subtract the initial thing from the final thing, we get the change. So here change in velocity we are going to talk about. So we have to subtract the initial velocity from the final velocity. So we get v minus u. This is only change in the velocity. Now I am going to write the rate of change of velocity. The rate of change of velocity. Rate means what? Velocity is changed. Change of velocity is happened. Here what does this rate refer? This rate refer how fast that change in velocity happen or how slow. Okay, that rate we get when we multiply with the time. So change in velocity by time is equal to v minus u by t. So what is the rate of change of velocity? This is acceleration. What is acceleration definition? The rate of change of velocity is called acceleration. Hence the rate of change of velocity in the place of this, we can write acceleration now. So from the definition of acceleration, now we write the rate of change of velocity is called acceleration. That is equal to v minus u by t. Acceleration denoted by a. This is v minus u by t. When you bring the t from RHS to LHS, it becomes at and v minus u. Okay. Whenever you write this equation in this way, LHS is equal to RHS. When you transpose this minus u from LHS to RHS becomes plus u. At plus u. Okay. At plus u can be written as u plus at, because a plus b is equal to b plus a. So this is the equation we got. This is the first equation of motion. Okay, so please note down this derivation part. See, derivation part okay for understanding purpose, but learning equation is very important. Even though if you don't learn this complete derivation part, it is okay, it works. Okay, learning things is good, but okay, it works. But if you don't learn the formula, if you don't have this formula in your mind, how do you solve the problem? To solve the problem, what do we need? Formulas, right? So this is the part of derivation of the formulas. You have to note down the formulas and learn them, please. Okay. Just now we have discussed and we derived the first equation of motion, that is v is equal to u plus at. Now we are going to derive the second equation of motion. So second equation of motion is s is equal to ut plus at square by 2. S stands for distance. Distance in one direction is called displacement. So displacement, because we assume that object is moving with a uniform acceleration, so it travels in a straight line. U initial velocity, time, a acceleration, t time. So especially this gives you the relation between the distance and the time. That is why second equation of motion is also called displacement to time equation. It is also called what, Nana? Displacement to time equation. With the help of this second equation of motion, mostly we find the displacement and the time. It gives the main relation between displacement and the time. So as we have discussed previous, let's say object is moving with a uniform acceleration, starts with a certain velocity u. After some time, after covering certain distance s, the velocity of the object has been changed to v. Okay, so u is the initial velocity, v is the final velocity, t is the time taken, and s is the distance traveled. Okay, or displacement. Now average velocity. Now we are going to find the average velocity of this body. What is the initial velocity? U. What is the final velocity? V. So in this particular aspect, we are going to find the average of these two velocities. So mathematically, how do you find the average velocity? Sum of the observations by number of observations. Here we are talking about how many quantities? Two quantities. One is the initial velocity, other one is the final velocity. Now we have to find the average of those both velocities. So how do you do? Sum of the observations by number of observations. So average velocity is equal to u plus v by 2. Okay. But in physics, in kinematics, already average velocity we have discussed previously. Okay. So what is the average velocity formula? Average velocity is equal to total displacement by time. Okay. So displacement by time. So average velocity is equal to s by t. Okay. So this is equation 1. Okay, this is equation 1. Let's say this is equation 2. In equation 1, what do we have? We have average velocity as left hand side. Equation 2, it is also average velocity. Okay, when LHS are equal, we can write the RHS equal. So we can make these two equations equal. Okay, by equating 1 and 2, we get u plus v by 2 is equal to s by t. U plus v by 2 is equal to s by t. Okay, actually there is separate derivation we have for this average velocity u plus v by 2. Okay, right. Now here we have, what is the v value? V is equal to u plus at. Since we know that from the equation of motion v is equal to u plus at, this value we are going to substitute in this. If you substitute, u is as it is, in the place of v we are going to write u plus at by 2 is equal to s by t. U plus u, 2u plus at by 2 is equal to s by t. So this can be written as 2u by 2 plus at by 2 is equal to s by t. Okay, so here now we are going to write this. Now 2 get cancelled. Okay, right. Okay, 2 get cancelled. Now the remaining u plus at by 2 is equal to s by t, right? Now I am transposing these two from RHS to LHS. Then this 2 which is dividing s multiplies this u plus at by 2. Then I write this as s is equal to t comes towards LHS and multiplies these two, u plus at by 2 into t. S is equal to u into t ut plus at into t at square by 2. Okay, so we got this second equation of motion. This is s is equal to ut plus at square by 2. So this is the derivation part of the second equation, okay, of motion. Please learn the formula. Derivation is okay, whether you remember the derivation or not, it is up to you, but learning the formula is very, very important. Please, you have to learn the formula. This is second equation of motion. Please note down. Just now we have derived the second equation of motion. Okay, so what is the second equation of motion? S is equal to ut plus at square by 2. Now we are going to talk about derivation of the third equation of motion. Okay, what is that? V square minus u square is equal to 2as. This is third equation of motion. V stands for final velocity, u stands for initial velocity, a stands for change in velocity, s stands for displacement. So this formula especially gives the relation between velocity and displacement. That is why this third equation of motion is also called a velocity displacement equation. Velocity displacement. This formula especially gives the relation between displacement and velocity. To find the velocity and displacement, we use this formula. So this part of the derivation as it is remains the same up to here. Okay, from here onwards a little changes we do. So already we have discussed average velocity. This is equation 1, this is equation 2. When we equating 1 and 2, we get this formula. Okay, from here onwards you see up to here it is same. Now what is the first equation of motion? V is equal to u plus at. Now I am going to write this formula in terms of t and m. Okay, then at plus u is equal to v. At is equal to this plus u, if you transpose towards RHS becomes minus u. T is equal to, here a multiplies t, if you transpose to RHS, okay, becomes divisor of v minus u. This is the t value. Now this t value we will substitute in equation 3. Let's say this is equation 3. After equating 1 and 2, we got equation 3. So substitute t value in equation 3. This t value we have to substitute in equation 3. If you substitute, what happened? What do you get here? Okay, so the remaining part of the derivation is this. U plus v by 2 is equal to s by, in the place of t, we are going to write v minus u by a. Now we are going to do the cross multiplication. This is into this is equal to this is into this is, right? So u plus v of v minus u by a is equal to 2s. You can transpose this a from LHS to RHS. Then what happened? This u plus v also can be written as v plus u, because a plus b is equal to b plus a. V plus u into v minus u is equal to, if I transpose this a is dividing LHS. Okay, if you transpose from LHS to RHS, this multiplies 2s, 2as. This is we know in mathematics one of the important identity, a plus b into a minus b is equal to a square minus b square. Using that, we can write this is as v square minus u square is equal to 2as. So this gives you third equation of motion. Okay, so this is the derivation part of three equations of motion. So the next equation of motion also we discussed. Okay, but after solving some important numericals related to these three equations of motion, we discuss the fourth equation of motion. So meanwhile, you learn only the formulas, equations of motion. Please learn first equation of motion formula, second equation of motion formula, and third equation of motion formula, because in the next coming videos we are going to solve the problems. To solve the problems in a better way, compulsory you have to keep these formulas in the mind. Please note down and refer.